All right, cool. Day 11, and I'm starting right on time today, so I can get done. And got a lot of things going on. Your audience will see it in a moment. Get ready. You are live. All right. So let's check this problem out. Oh, chronal charge. Yeah. Okay. Good. You watch the elves and their sleigh fade into the distance as they head toward the North Pole. Actually, you're the one fading. The falling sensation returns. Low fuel warning light is illuminated. Tapping at once causes a pair to hologram the situation. A 300 by 300 grid of fuel cells in the current power level is some negative. You're not sure what negative power means, but it can't be good. Each fuel cell has a coordinate ranging from 1 to 300 both the x and y direction. XY notation, top left cell is 1, 1. The top right cell is 300. 1. Okay, the interface lets you select any 3x3 square of fuel cells to increase your chances of getting. You decide to choose the 3x3 square with the largest total power. Power level in any given fuel cell can be chosen by the following coordinate. Find the fuel cell's rack ID, which is the x coordinate plus 10. Pin with the power level of the rack ID times the y coordinate. Increase the power level by the value of the grid serial number. Set the power level to itself multiplied by the rack ID. Keep only the hundredths digit of the power level. Try with the power level. For example, to find the power level of the fuel cell at 3,5 in a grid with serial number 8, the rack ID is 3. Blah, blah, blah. 3x3 squared has a large total power. Just be entirely within using the XY coordinate top of the fuel cell. All right, that's a lot of stuff. Let's just get cracking on it and see what chronal charge pi. And let's bite this off piece by piece. Power in a given fuel cell can be found with the following process. Find the fuel cell's rack ID, which is x coordinate plus 10. And the power level of the rack ID times the y coordinate. Increase the power level by the value of the grid serial number. Set the power level to itself multiplied by the rack ID. Keep only the hundred digit of the power level. Subtract 5 from the power level. Okay. So we want to say, what do we call this? Def power level, x is an int, y is an int, and then we have a grid serial number, so I'll call that GSN, which is an int, and that will return an int. And so so let's say rack ID equals x plus 10, power equals rack ID times y, increase power level by the value of the grid serial number, power plus equals GSN, set the power level to itself multiplied by the rack ID, so power times equals rack ID, keep only the hundredths digit of the power level. So 1, 2, 3, 4, 5 becomes 3. So in order to do that, I want to do keep only the hundreds digits. Power equals power int division by 100. So 1, 2, 3, 4, 5 is 1, 2, 3. And then I can just mod it by 10 to get the digit, and then subtract 5, power minus equals 5, return power. Okay, so let's write some asserts. Assert power level, and what did they say? At 3, 5, 8, that equals 4. Assert power level of 122.79.57. That equals minus 5. Assert power level of 217.196.39. 196.39 is 0. And assert power level of 101.153. 101, 153, and 71 is 4. Okay, so let us just run this. Run day 11. Okay, so those all pass. So now let's get to the rest of the problem. Your goal is to find the 3 by 3 square which has the largest total power. The square must be entirely within the 300 by 300 grid. And I think we can just brute force this. So let's say all squares, and let's say n int equals 300, so we'll say that. And so I'm just going to use my indexes and figure it out. So we need to put in a GSN, which is an int, and some n. So 300 times 300 is what? 90,000. So I can just do that. That's easy enough. So let me just do this and say GSN equals let's say let's do find the best with the GSN, which is an int, and that will return an int. Is that the int? X, Y coordinates. No, it'll return a tuple of ints. So, from typing import tuple, this will be a tuple int. And so let's say, what did I call these? Power levels. So power levels equals power level X, Y, GSN. So we're just going to do a list comprehensions for X in range 300, for Y in range 300, and this shouldn't be too bad, I don't think. And now what I want to do is I want to say return, and I want to find 3 by 3 squared has the largest total power. So I want to return max of XY for X in range, let's say 298. I feel really bad about hard coding all these numbers for Y in range 298. And so what's the key? The key is going to be sum of power levels ij for I in x, x plus 1, x plus 2, for j in y, y plus 1, y plus 2. For grid serial number 18, so print find best 18. Let's run this and see how long it takes. Generator expression must be parenthesized if not sole argument. Okay, that's fine. Name x is not defined. Key equals lambda pair sum power levels ij for I in Python 2 I could have let me do this, pair 0 plus I pair 1 plus j. for I in range 3, for j in range 3. So you can't do destructuring of variables and lambdas in Python 3. You could in Python 2. Forgot a parentheses. And this says 4533, which is backwards. So let me think about how I want to do that. Because x is, let me see how they're calling this. X horizontal, the top left cell and the top right cell is 301. So so that means that top left cell is 1, and the top right cell is 301. So they are backwards, and this is sort. This is a real nuisance for me that they're doing these things. And why is that? So I need to do for y in range 300 and for x in range 300 down here. And now let me run it. 3345. Okay, that's good. And then and for 42, so let me just turn that into assert. Assert find best 18 equals 3345, and assert that find best 42 equals 2161. Is that right? 2161? Yeah. Assertion error equals oh, because I need to parenthesize these. Okay, and so now I want to, I have 2187, so I want to print find best 2187. And that says it's 235.85. So 235.85. That's the right answer. Continue to part 2. Discover its dial on the side of the device. It seems that you select a square of any size, not just 3 to 3. Sizes from 1 by 1 to 300 by 300 are supported. Using this, you now must find the square of any size with the largest total power. Identify the square by including its size as the third parameter. For example, for grid serial number 18, the largest total square is 16 by 16 and has a top left corner of 90. So its identifier is that. For grid serial number 42, so the brute force way here is going to be very slow. Power levels is fine. So now what I want to do is max xy, and I'll call this S, for x in range 298. And so now the square can be any size, right? 1 to 1. So x in range 300, for y in range 300, and for s in range. And so what can I do? I can do the smaller of 300 minus x and 300 minus y, right? And that is not going to work because suddenly, actually that will work. But this is, it's not going to be a pair anymore. It's going to be trio, trio I plus 1, trio I plus j for I in range trio 2, and for j in range trio 2. So that will work. And let's call this find best 2. Problem is it's going to be really slow, right? So if I run this and I say find best 2 18, it's just going to run for a really long time. It might not. Maybe I don't care. But there's probably something smarter we can do about using using previous results, and that's as follows. So we do the power levels, and now we have the results equals this. And so what I want to do is I want to say for S in range 1, let's say 301. So this will be the size of our square. And so what we can do is, this will just give us a sense of how slow it is. You know, for x in range 300 minus s plus 1, I think. For y in range 300 minus s plus 1. Is that still running? No, it's... So let's think about what the smartest way to do this efficiently is. So if I want to do a square of 1, I just go around and look at all of them. So that's easy. If I want to do square of 2, I go around and basically I can if I have like the 2 by 2, then that's just going to give me that I just need to add in, you know, around the corner. So so let's try doing that. Results equals x, y, 1, power levels x, y, for x in range 300, for y in range 300. Okay, and so now for s in range 2, 301. So let me think if that's the best way to do it. That's not terrible. Okay, so for x in range, and again 300 minus s plus 1, for y in range 300 minus s plus 1. Okay, so what I want to say is power equals results x, y, s minus 1. So we have that. And then now I need to add on another, you know, for I in range s. So if I have like a 10 by 10 and I go, now I'm going to do 11 by 11, I get 10 by 10. Power plus equals power levels So what do I want to do? I want to do x plus s, y plus I, and then power plus equals power levels x plus I, y plus s, and then power plus equals outside of this power levels, and we'll see if this is good enough or not, x plus s plus 1, y plus s plus 1, and results x, y, s equals power. And let me just print s so we can see how fast we're going. And so find best 2 of 18. So let's just try this. Let's run it. List indices may be integers or slices, not tuple. That is correct. So I didn't slice these correctly. And let's see if this is fast enough. List index out of range. So let's print x, y, s. 0 to 97, 2. Do I have an off by 1 here slightly? So if s is 2, yeah, I think I have an off by 1. No, I don't think I do, but that's still the problem. So even with that fix, so let me think about this. I have that power for I in range s, print x plus s, y plus I, print x plus I, y plus s, print x plus s plus 1, y plus s plus 1. Three. Print a blank one for each of them. I need to stop doing that. Run it again and do find best. Okay. 300. So oh, so this is not quite right. So so what I need to do here is s minus 1, and then x plus s and y plus s, and I think that will be right. No, that's not right. For I in range, let me try this again. X plus s, y plus I, print x plus I, y plus s, print x plus s, y plus s, and figure out. So I still get this let me just do this, and then I don't know what happened there. So print x, y, power. So that will help me a little bit. So I have 0 to 98. So now I want to do 2. So I'm going to do 0 to 98, and then I want to do to 298. Why is that? So I'm at 0 and 298, so I've already done that. So now I want to go 1, 298, and I thought I changed this. Okay, so like I have 298, 298, and now let me just do it this way. 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2. And so I've already got 1, 1, 1. So now I want to do 4x in range. So let's do 1, 1, and I want to do, and now I say I'm going to s equals 2. So I take power is 1, 1, 1. And now for I in range 1, I want to do same x. No. So sorry, this is so let's say xy equals 1, 1. So need to get 1, 2, and then I also need to get a 2, 1, and then I also need to get 2, 2. So let's figure that out. And you know, if let's say I had 1, 1, 1, 2, and maybe that's a better one to think about because so let's say I had both of these. So this is 1, 1, 2, 1, blah, blah, blah. So I want to go up to 3. So this plus this minus 1, x plus s minus 1, y plus I, x plus I, y plus s minus 1, and then finally x plus s, y plus s. So I feel like that's right. But again, I get a list index out of range at, what am I printing? Print x plus s minus 1, y plus I. Print x plus I, y plus s minus 1, and then print x plus s, y plus s. Let's run it. And I'm still getting, when I'm at 0, 298, so I do 1, 298, 0, 299, and that's good. And then I also need, I guess this is also minus 1. And so let's get rid of these print statements. And this is also like really slowing down. Because each time it's so that can't be the right way to do it either. So after wasting all that time, well, so let's think about how we can do it even faster, because that's not fast enough. Yeah, that's crawling along. So find best 3. It's a GSN int, and let's do that again. So that's just crawling along. So we'll let it crawl and see if it gives the right answer, and if it does, then we'll run it for our actual input. But let's figure out an actual faster way to do it. So, one thing we could do is basically look at every vertical stripe, right? And so if we have every vertical stripe, then we can just add those up, and that might make our lives easier too. Or I could let this run, but it's really slow. So so power levels is that, and then vertical stripes equals so for x in range 300, for y in range 300, for h in range so 300 minus y, or no, we'll just do height 1. So we'll say x, y, y plus 1, and power level xy. Power levels xy. So that will give us, again, the vertical stripe with just, so that actually ran. Unfortunately, it didn't do anything. All right, you know what? I'm just going to run this again, and then I want to return max of results.keys. Key equals lambda key result. Key equals lambda k results k. And that will return me the square root of the largest total power. So do I want to do it for 18 again? Maybe. The thing is, it's not going to help. If I get the wrong answer that way, I'm going to get the wrong answer that way anyway. So maybe I better just do this. Let's just say best equals none, best value equals minus infinity, results x, y, s equals power. So if power is bigger than best value, best equals x, y, s, best value equals power, print x, y, s, power. Okay, so and so now I want to do find best 2 of 2187. And it's still going to take a while, but we'll run it anyway. So 233, 40, 13, 98 is our best so far. So this will just chug along, but let's still think about how we would do this. And I see it. So it gets slower and slower as it gets up to 150, and then it will start to get faster again once it gets on the other side of that. So you'd like to do some kind of dynamic programming thing, which is I thought what I did, because you have this nice sub-problem. But maybe I have the wrong thing. I mean, so the right way to handle it would be to say so maybe that's the issue, is that I wasn't very smart about my dynamic programming. So for instance, what if I do find best 3 and I'll get rid of this. Actually, I won't get rid of that. And so I'll say I have this, right? And so oh, but these are only squares. Okay, so what I want to do is I want to do something like the following. If I have this, and I want to get to this, then I take the square, so that's not actually that helpful, but what I could do is, no, that's not that good either. I'm probably just going to wait this out. But one thing I could do is I could do every possible rectangle, right? So if you want to do every possible, no, that's closer to what I was doing before. I don't like that one much either. So I'd like to, I have this square, and I'd like to get to the bigger square. And that's what I did here, but I did it by like 1, 2, 3, 4, 5, which is slow, because you do that a lot. And so if you did every rectangle, I would, no, I don't like that either. It's possible I got an off by 1 here, and I'm going to get the wrong answer anyway, which would be unfortunate. But still, the best I've done is this 233, 40, 13, 98. So, and you can see it starts to speed up at the end. And it didn't do anything because why? Because I didn't run it. I ran find best 2. Oh, right. But still, I don't understand why I didn't return anything. Well, I printed it along the way, which is good. So let's try that and see if it works. 233, 40, 13. I have this weird feeling that that's not actually right. But we can try it. That is the right answer. All right, so that was pretty unsatisfying, I would say. We just kind of did a slow brute force, and it was pretty unsatisfying, and there were a lot of off by 1 errors. But it worked and got us the right answer. And yeah, I'm not super excited about that one, but I will get committed anyway. Day 11. Get push. So yeah, a lot of sitting and watching, and I still feel like there must have been a much better way to do that than what I did. What I did worked. It worked really slowly, but it worked all the same. So I guess that's good. So thanks again for watching. Find me on Twitter, find me on YouTube, find me on Patreon, and I guess I will be back with day 12 tomorrow. So yeah, sorry this wasn't more thrilling. This was one of the less thrilling days, I would say. So yeah, it is what it is.